Hi everyone. In this video, I am going to explain about parallel in serial out shift register. Parallel in serial out shift register is the last type of four shift registers which we have discussed earlier. Serial in serial out shift register, serial in parallel out shift register, parallel in parallel out shift register, and now this is parallel in serial out shift register. Okay, parallel in serial out. So PISO parallel in serial out shift register. That means in this particular shift register, data enters parallelly and leaves serially. Data enters parallelly. That means data enter to the registers parallelly. That means at a time, all the 4 bits will be loaded into the flip-flops parallelly, and the data will be moved bit by bit, bit by bit. This is what parallel in serial out meaning. And now let us see how to construct this parallel in serial out shift register. But the construction is not easy, as we have seen in the previous 3 cases. This construction involves additional logic circuitry, because data has to be loaded and as well as the data has to be moved serially among the flip-flops. Okay, consider 4-bit parallel in serial out shift register. So 4-bit parallel in serial out shift register needs 4 flip-flops and also needs additional gating circuit. It needs a mode select switch. That means whether the data is moving or loading, that will be selected by the mode select switch M. Okay, so now let us draw the circuit diagram. So first you need to draw 4 flip-flops. This is parallel input. All these are D flip-flops only. So for all the construction of shift registers, we have used D flip-flops only, and these are the outputs. And for all the flip-flops, we have clock signal, which is common to all the flip-flops to say all the flip-flops are working synchronously. This is clock signal. And now reset pin. Reset pin is also common to all the flip-flops to reset at a time whenever it is needed. This is reset pin. Now, this is data in D of 0. Data in D of 0. Now we are using the additional circuitry in this particular 3 flip-flops inputs. So observe here what I am doing. 2 AND gates. The outputs of these 2 AND gates are connected to a OR gate. So the output is connected to D flip-flop. Again the same circuit. 2 AND gates. output is connected to OR gate, two AND gates. This is OR gate, and then D flip-flop. At last, the output is nothing but serial out because the data goes out serially. Okay. Now, the first flip-flop output is connected to one of the AND gates here, and again here one of the AND gates, again here one of the AND gates. Next, here this is what the data out input 1. This is the data input 2. This is the data input 3. Now, take the mode signal, which is very important in the entire operation. Mode signal, one is a direct signal, another one is the complemented signal. Another one is the complemented signal. That means one works with 0, another works with 1. Okay. Now, one is connected to the first, true form is connected to first AND gate. True form is connected to first AND gate. Complemented form is connected to second AND gate. Complemented form is connected to second AND gate. Now check the operation. This is the circuit, final circuit. Now check the operation. This is the mode M. Now tell me what happens when mode is equal to, when mode M is equal to 0. Which operation is going to be performed? Mode M is equal to 0 means here it is 0, here it is 0, here it is 0. Now this 0 is connected here, this 0 is connected here, and this 0 is connected here. What about the second line? Second line is connected as 1 because M is equal to 0, that will be inverted to 1, and now here it is 1, here it is 1, and here it is 1. If one of the inputs of AND gate is 0, irrespective of other input, output is 0. If one of the inputs of AND gate is 0, irrespective of other input, output is 0. If other input is 0, output is 0. If other input is 1, then also output is 0. Here also it is 0. Here also it is 0. What about the second one? Second AND gate, one of the inputs is 1, and then if D of 1 is 0, then output is 0. If D of 1 is 1, then output is 1. That means simply here, whatever the D of pin connected, that will be the output of AND gate. Again, here also it is D of 2. Here also it is D of 3. And then it is D of 1. OR gate output is same. Whatever the D of 1, D of 2, D of 3 connected, the same will be the output. Okay. So, the same outputs are coming. And here D of 0, D of 1, D of 2, D of 3. What is the operation going on? Parallel input loading. So, here parallel loading is done. Parallel loading is done for mode is equal to 0 operation. Now, can you guess what happens when M is equal to 1? When M equal to 1, just the cases are altered, and then what happens? See, this pin, okay, I will show it a different color. Okay, green color. See, when M is equal to, when M is equal to 1, and M is equal to 1, what happens? Let us see. This is 1, this is 1, and this is 1. And this second pin goes 0 because M is equal to 1, that is inverted as 0. And now this is connected here 0, 0, 0. And now first pins are 1s, just the case is altered. As first pin is connected to 1, first AND gate, one of the inputs is 1. Whatever the output that is coming here, the same will be the output. Again, the same will be the output of OR gate also. So what is the output here? Here the output is Q of 0. Let us consider this as Q of 0 and this as Q of 1 and this as Q of 2 and this as the output, last one S naught. The same output will be here. Again here also same output Q of 1. Again here also same output Q of 2. Because this output is 1, this AND gate input is 1 and this AND gate is 0. Again here it is 0, here it is 1. Again here it is 0, here it is 1. So the output of AND gate is simply whatever the Q naught says, that will be the output here. And again here also Q of 1, here also Q of 2. Again that will be the output of OR gate. So what is happening? Once the clock is applied, the data will be moving on. So shifting operation is done. Shifting operation will be done. Shifting operation, that to parallel shifting. Sorry, serial shifting. Serial shifting. Serial right shift operation is being performed when m is equal to 1. When m is equal to 1. So depending upon the mode pin, the data can be moved or parallelly loading operation is being performed, depends upon the mode pin. Okay. So here the mode pin decides the operation of parallel loading or serial shifting. Okay, this is parallel in serial out shift register. Parallel in serial out shift register. In the next video, I will explain about the VHDL code for this parallel in serial out shift register. Thank you.